Here is Chapter 9, Exercise Set A. Chapter 9 exercises are structured pretty much the same way as those of Chapter 8. In Set A, we deal with the interval estimation, and in Set B, we do hypothesis testing. Let's begin Set A. Here's problem 1. The following observations were made on fracture toughness of base plate of 18% nickel maraging steel. And we have these 22 measurements, which correspond to sample, and we have the sample mean and the sample standard deviation. Now, what about the population? The population must be about the entire base plates made by this particular company in a certain time frame. That can be humongous, and that's what we want to infer using these problems. Subproblem number 1. Why do we use T-curve? Why not Z-curve? Well, there were 3 criteria here. Number 1, the original distribution is believed to be normal, and that's clear because we are talking about observation. When you do observation or experiment, we assume normal without really saying, unless specified otherwise. Number 2, standard deviation is unknown, or closer to unknowable in this case, because this is, as we said earlier, it's about observation or experiment. The sample size is small, just 22, so that's T-curve problem. So let's use student's T-curve in these 2 problems, and the first problem is about confidence bound, 99% lower confidence bound. How do we begin? We begin with a picture. Here is the typical process: outline, center, end, and then shade. Here we go. Outline of the student T-curve, which is almost exactly like normal curve. So if you just use hand-drawn picture, whether it is T-curve or Z-curve, you cannot tell. Alright, center is of course a mean of 77.33, and the 99% or 99% lower confidence bound, and that's the X value you're looking for. And finally, shade. I used 2 color shading, blue here and red over there, but if you use just one color, well, that's fine with me. Alright, now how do we use this picture to get this problem done? Here is typical method. T-score is end minus center over standard error, and in this particular case we have these approximate values. X we don't know, and 77.33 is the center, that's the sample mean. And what is SE? The sample standard deviation is 5.037, so 5.037 divided by square root of the sample size. Here we go. This is a T-score that we have to get, and you can look up the T-table to find out the T-score associated to 1% to the left and 99% to the right. Shall we look up the table here? Here it is. And this table is based upon right-hand side shading here. What we want instead, we want left-hand side shading, so we need a negative sign. Alright, what's the degree of freedom? Is 21 because sample size was 22. So 21 row is here, and then we want 1% to the right, so 2.518, but 1% to the left. That's how you get negative 2.518. Solving this equation with respect to x, you're gonna get what you want. Here is the solution. Here's the equation, and well, okay, here is the equation, practical equation with all those numbers. Flip the denominator, flip the mean, calculate. We have 74.63 approximately speaking, and that is the conclusion. That is the 99% lower confidence bound. Okay, now that we went through a confidence bound problem, let's go through a confidence interval problem. This time we have to shade similarly but symmetrically. Outline, center, end, and then shade. And this is the outcome. The middle part should be 95%, and we want this x1 and x2. 2.5% here, 2.5% there. For z-curve problem, we usually find x1 using appropriate z-score, and then use symmetry to get x2. Change negative sign to positive. For t-curve, I usually go with the right-hand side. X minus the center. I need bigger font, by the way. Okay. Over the standard error, 5.037 over square root of 22. By the way, was 5.037 correct? Yes, that's right. And that is the t-score that we have to identify. And what's the t-score associated to this x2? Right hand side, we get 2.5%, right? Here's the table. Same table. This part has to be 2.5% for degree of freedom of 21. And here we go, 2.080. Another way, you're looking for 95% confidence level and use this column and then look for the degree of freedom of 21. Same way. Personally, I prefer to use upper tail probability because it's more versatile. Not just for confidence interval, we could use the same idea for confidence bound as well. But I saw many students who use this 95% there and use the column backward. Anyway, the t-score you're looking for is 0. Did I say 0 point? Excuse me, 2.080. So this is 2.080. If you want to look for this x1, and this will change to negative of 2.080, but if you're looking for x2, this is positive. Solving for this x, you're going to get x2, and then you can use symmetry to find out this x1. Here is the solution. Here's the equation. Flip the denominator, and then flip the mean, and run the calculation. Use the symmetry. You're looking for the left-hand side, so change plus to minus, and that's it. Here is the conclusion. Okay, let me make this picture a little bit smaller so that everything fits into the same viewing window. And okay, here we go. x2, x1, using the symmetry, this plus becomes minus because right hand side goes to the left hand side, and consequently we have this shading, this picture, and here is the conclusion. 95% confidence interval is about 75.1 to 79.6, approximately speaking.